During intermittent sprint activities, such as the sprint cycle test, all of the energy systems would be used, but it would depend on the intensity of the particular point of the exercise, which would determine which energy system would be used. Each of the short bursts of intensity sprints use the ATP-PC and utilizes anaerobic glycolysis in which lactic acid is produced. Heat is a general waste product, and ATP and PC stores are depleted and resynthesized to produce 10 seconds worth of energy. There is generally an insufficient time to recover completely after each high-intensity sprint, leading to the increase in lactic acid. During the ATP and PC system being used, ATP and PC stores will be used up. Then when the lactic acid system is used, it relies on anaerobic glycolysis for its production of ATP. The aerobic system uses a combination of glycogen, fat, and carbohydrates to provide energy. In order for performance to be efficient, the removal of lactic acid is required to limit muscle fatigue. However, at some point in these activities, athletes will fatigue at some point or another. This could be due to the reduction of calcium ions, which are stored in the cytoplasmic reticulum. This is because it has been found that after extended high-intensity exercise, small channels in the athlete's muscle cells leak calcium. This calcium leak weakens muscle contraction and stimulates an enzyme that attacks muscle fibers, which results in the fatigue of the muscle. If no calcium ions are available, the muscle is unable to contract. It is important that calcium is released, as it allows myosin and actin to combine to form actomyosin, which aids muscle contraction. Another way in which fatigue is caused due to the decrease of potassium ions, which makes the nerve impulse the muscle tissue slower, or is severely reduced, and this reduces depolarization. Also, the release of acetylcholine stimulates skeletal muscles and the parasympathetic nervous system. The reduction from the enzyme acetylcholinesterase prevents the nervous stimulation from reaching the muscle tissue and motor units. Neuromuscular fatigue means that the muscles are not able to receive signals from the central nervous system. For example, the reduction in cholinesterase means that it stops vesicles containing the impulse along the nerves, so the muscle tissue is unable to function properly. In order to reduce neuromuscular fatigue, athletes must force their neuromuscular system to adapt to a high level of development. The end result is that this type of fatigue you experience during the physical activity conditions your body so that other types of activity the athlete performs in will be less stressful. An example of conditioning could be progressive resistance exercises. Athletes use free weights or machines to provide this, using a weight they can lift and lower for no more than 90 seconds before having to rest is the appropriate resistance for this type of training. Recovery for intermittent sprint tests is quite short because the test itself has numerous stops and pauses, which allows the body to take in oxygen continuously, meaning it can begin to resynthesize the ATP and PC.